We saw Ampere-Maxwell's equation, right? So what can we infer from this particular equation? There are certain experimental observations. So under that first one is, see, the conduction and displacement current are individually discontinuous, but the two currents together possesses the property of continuity. Alright, so if you take just the conduction current or just the displacement current, they are discontinuous, but together they will become continuous. Okay, this is one of the observations. The second observation is the displacement current is precisely equal to the conduction current when the two are present in different parts of the circuit. Okay, if they are connected in the same circuit, they are not equal, but if they are in the different parts of the circuits, they are equal. So IC is equal to ID in such cases. Alright, the next one is the displacement current arises due to the rate of change of electric flux or electric field between the two plates of the capacitor, right? So this is what we noticed. That's how the displacement current arises. So see here, just as the conduction current, the displacement current is also the source of magnetic field, because displacement current is also change in electric current. So if we have change in electric current, obviously magnetic field will be produced, right? So what are we looking at in this particular experiment is, see, we have the displacement current which has electric field and magnetic field, and we have conduction current, even that also produces magnetic field, right? But the difference between these two is that the conduction current produces magnetic field due to the charges in motion, okay, charges which are in motion, whereas the displacement current produces magnetic field due to the time rate of change of electric field. That is, the small time duration what we are considering, that is changing because of the varying magnetic field, right, and the varying electric field also. So what we have is, between that small space between the two capacitor plates, there is electric field as well as magnetic field, both of them, correct, and both of them exist together. So this is the point where electromagnetic waves are produced. Okay, so between the two plates of the capacitor, so this is where the EM waves are produced, or electromagnetic waves are produced. Alright, see here, the varying electric and magnetic field is there, right? This is perpendicular to the direction of propagation of electromagnetic wave. Okay, this is perpendicular. So what we can confirm from this is that between those capacitor plates, we are actually producing an electromagnetic wave. Okay, so these are certain experimental observations, and using the formula we can actually tell that the conduction current and displacement current both are equally important in getting an electromagnetic wave.